Alright, hi guys. So I'm going to be doing a quick recording on dynamics, and this is actually quite a long chapter, right? So once again, a quick reminder that downloading the content in your head is only about 20% of the work. So after you watch these videos, you still got to make sure you do enough practice. You can head over to the website and do the questions tagged to the learning objectives, right? So these learning objectives are from Cambridge, and they sort of tell you what the exams can test. Okay, so first and foremost, right, the first learning objective is actually to identify the difference between contact forces as well as non-contact forces. Okay, and they've even given you examples of what contact forces are. Okay, so a contact force, right, just refers to any force that actually requires physical contact to be exerted. And a non-contact force refers to forces where you don't have direct physical contact, but you rather have like force at a distance. So you don't need to be directly touching something. Okay, but before we even dive into that, what is a force? Now, simply put, actually a force is just a push or a pull. Okay, and in particular, right, a net force, also known as a resultant force. So if you have like some object, right, and there's nothing like balancing that force. So in other words, if you have a resultant force, like a force that nothing else opposes and balances, then it actually can cause a change in a few things of the object. For example, it can cause either the shape to change or it can cause the motion of the object to change. Okay, so a couple of things like, okay, actually there are five things that it could do. It could make an object that wasn't moving start to move, and we call this acceleration. It could make an already moving object move even faster, right? So it's the same thing, can make an object speed up. Or it could do the opposite, it could also make an object slow down. So imagine if you have like a ball rolling, right? And then you have a force to oppose its motion. Yeah, then you would slow it down. Okay, you could also change the direction of the object, or you could change the shape of the object, or you can make an object that wasn't originally moving, move, or you could make a moving object stop. Yeah, so these are the different effects of the force on an object. Okay, and so yeah, you have to remember a couple of things. Firstly, force is a vector quantity. So whenever you're considering force, right, make sure you take the resultant force, right? Which is why we got to be careful about when we talk about forces, right? Whether or not we're talking about one of the force or the net force. Okay, so if you see the phrase net, just take note, it means total or resultant force. Okay, and you must account for the direction. So a very simple example here would be, let's suppose I have a box, okay, like this, and then I exert two forces on it. One is a bigger force called F2, and the other is a smaller force called F1. Then the net force, right, will just be the bigger force minus the smaller force. Okay, so the magnitude of the resultant force will be F2 minus of F1, and the direction will be the larger force, because you can think of it as like the bigger force F2 wins F1. Yeah, so the resultant will be in the direction of F2. Okay, yeah, so this is pretty much what you can think about for forces. Okay, so like I mentioned, there are two types of forces then. You have contact forces, and then you have non-contact forces. Okay, so here are the different types of contact forces that you could have on an object. So one of the forces that you get is actually a normal force. Now, normal here, right, doesn't mean ordinary. Okay, you got to understand when we use the word normal in physics, it actually means right angle. Okay, so if you take a look at my quick example here, let's say I have an object on a slope. Then the normal force, right, which I've labeled as N, is actually going to be right angle. Okay, so let me sketch this here, right angle to the surface. That's why we call it normal. Okay, have to make sure you understand what normal is. Right angle. Okay. Next, you also have other forces like friction or tension or air resistance. All of them actually require contact. Okay. Same as thrust and lift. Okay. So these forces, quite intuitive. You'll see them quite a lot in your practice. Okay. Frictional force, right, is a force that resists motion. So whenever you have a moving object, right, then there will be a friction to oppose it if there's like a surface that is rough. Okay. You also have tension, which is the force in the string. You have air resistance when you have an object trying to move against air, and you have thrust whenever there's like some engine or some motor pushing an object forward. Okay, finally you have lift. This one you don't have to worry too much. Usually it's like for a floating object. It could be like a helicopter or like could be like an airplane where there's something like pushing it up. Yeah, then we call it the lift. Okay, yeah, so these are some of the important illustrations to visualize. So friction always sort of opposes the direction of the motion. Then normal contact force is always right angle to the surface. Yeah, so tension we'll also discuss a bit later in the notes. Okay, now on the flip side, you also have non-contact forces. So like I mentioned, right, they do not require any physical contact. Okay, and instead, right, the moment you're inside like some field, okay, we call this like a region of space where if you put an object in, right, they will experience some force. This is what we call a non-contact force. So in your syllabus, there are only 3 types of non-contact forces that you need to care about. The first one is the weight. Okay, so weight is an example of a gravitational force. So when you put a mass in a gravitational field, then it will experience a gravitational force. This force is called weight, and it will point downwards towards the center of Earth. Okay, you also have electrostatic forces, which are forces between electric charges. And finally, you have electromagnetic forces, which are forces between magnets or moving charges. Yeah. Okay, so when you have moving charges like in a magnetic field, you also tend to get forces. Okay, so you'll learn about electromagnetic forces, electric forces, and weight in the later chapters. Okay, actually, weight you will learn later in this chapter. Okay, so these two, right, you will cover them much later in the future. Okay, but it's good to know that these are non-contact forces. Yeah, okay, so that's pretty much section 1. Okay, so in the next video, I'll head over to mass and gravity.